So let's check on how we can best select an equation, because that's the main thing, to select the correct formula. Once you know how to select the correct formula, even if you can make a mistake, there's a mark for choosing a correct formula and substituting. A mistake you've made won't cost you a lot. But imagine you were supposed to select this formula and when you selected this one. What? They won't even look at your substitution or whatsoever. It's just Pagani. It's wrong. So let's see. So the entire financial math is having, for your level, not the entire SE Universal. For your level in grade 12, we have two types of payments that are done. So there is a once-off payment. Once-off payment. Once-off payment is where you're saying, a person just pays once. Only once. You pay 500 to the bank, you wait for 3 years. After 3 years, you go to the bank, you ask for your money with interest. That's a once-off payment. Or you are purchasing a car cash, once-off payment. And then in the once-off payment, we have these 4 formulas. 2 of them are interest formulas. Interest is where something is increasing in value or gaining. And then you have depreciation. Depreciation is where something is reducing in value or decreasing. Again. Yes. So the first one is known as simple interest. Simple interest. How will you know that you have to use a simple interest? The thing is simple. To know that you have to use a simple interest, you read the question and identify 3 important words. The first one is inflation. Once you hear them mentioning inflation or population, maybe they say the population of town X and so on, or they mention a word on the question that says compounded, specifically after mentioning the percentage. Once one of these 3 is there, you do not use the simple interest. We'll see with the question. Simple interest, it should be simple. There must be no inflation, there must be no population, there must be no compounded after given the percentage. And then compound interest, you must have one of these. Once they say the price of bread is 18.50, how much will bread be if the inflation rate is 6.3%? They will say 6.3% per annum. They won't say compounded, but they have mentioned inflation, but it's compound interest. Population, they won't say compounded. You can say the population of Tembisa is growing by 10% per annum, compounded monthly. It doesn't happen like that. So you just say it is 10% per annum. And then the moment you see that they are talking about population, simply like that, you know that you have to use the compound interest. Depreciation, much easier. This one is a simple depreciation or a simple decay or a straight line. Straight line depreciation. You will see it by a negative. It shows that interest is actually, value is decreasing. Here is a reduced balance method. Reduced balance method. How will you see these two? Super easy. When you read the question, you will see it written. Using straight line method, you don't even think twice. You are going to this formula. Using reduced balance method, you don't think twice. Then you have the continual payment. The continual, which in a finance language, we call it an annuity. Simply means continuing or constant payments that are done. I am having an annuity. I'm having constant payments that are done. With the ones off, it is rare that the bank is paying you. It will be for what? It is you paying once to the bank. Just once, but then you wait until the bank will repay you. This side, it's a two-way street. You can pay the bank every month, and at the end of the day, the bank repays you, or at the end of a specific term. Or the bank can give you the money now, a large amount of money, and then you are repaying the bank small, bit by bit. So either way it can happen. But then one thing we look for is, this is a future annuity, this is a present. Future meaning the larger amount is in the future. For example, you are paying 500 every month for 10 years. For you to buy a house at the end of 10 years. Where is the larger amount? It's in the future. Because it will be smaller amounts that are constant for a bigger amount in the future. That means this is a future annuity. Unlike if you are getting a lot of money now, maybe let's say you win lotto, or you win, what do you call it? Betway. You win the Betway. And then you get something like 570,000. Then you take an amount now, you take it to the bank. Let's say you say, let me take 300,000 to the bank, and then the bank starts to pay you every month. You are earning every month. Obviously, a lot of people are not doing this, isn't it? Because when you get a large amount of money, you don't want it to be at the bank, you don't want it to be on a certain savings. You want to smash out. Then you will be on, I don't know. So this one will be a present annuity because the larger amount is present. So what's important? First, identifying this. You can't say, let me choose between these when you are not sure whether the payment is once-off or continual. So when I read the question, I want to identify, did the person pay once or did he pay continual? And if they paid once, you have 4 options. Is it interest or is it an asset that is depreciating? If it's interest, you are down to 2 formulas. Out of the 2, you seek for those 3 words I wrote here: population, inflation, and compounded. If you find them, you go to compound interest. If you don't, simple interest. It's simple as that. Let's see a question here. We'll read it together and identify, is it once off or continual? They say NOMSA started working on the 1st of January 1970. At the end of January 1970 and at the end of each month thereafter, she deposited. That statement alone is telling us. It says at the end of January 1970 and at the end of every month. That means she paid continually. We have to understand the question. She paid continually. She deposited 400 into an annuity fund, meaning it is a continuing fund. It is continuing where you are actually paying continually. So let's check. It is a continual payment. So we are coming to these 2 formulas. If I'm marking and I see someone even written any of that, let's not make sure. So let's ask ourselves, in 1970, did she receive a large amount? No. But she was already paying. It means her payment was for the future. It was not present. So that means we are going to select the future annuity amount. Remember, I have not even read a lot about the question. All I'm doing is identifying the equation. Then I write the equation. It's f is x into 1 plus I and minus 1. So now we need to know what each of them mean. The A here is the future amount. Future. The P is the present amount. And then the I is the interest rate. And then the N is the number of years. This is not number of payments, number of years. Coming this side, N is the number of payments. Number of payments. To calculate it, you simply take the number of years multiplied by the number of the compounding. If they say monthly, multiply by 12. They say half yearly, multiply by 2. X is the constant amount. Constant, or that continual amount, is the fixed amount. If someone is paying 500 this month, next month 700, the other month 900, that month 500, it cannot be X because it's not constant. Then F is the future amount, and then I is the same, is the interest rate. Then here P is the present amount, is that one of a loan. Present amount, this one is the future amount. And then X and N are the same. So once you have chosen a formula, guys, you then collect data with one goal. You know which formula to use. Therefore, I am expecting these variables to be present and one of them to not be known. That is my expectation. There's no need for me to look for A or for P. Why? I know I'm using this formula. Then I read the question now. So to pass it, guys, with flying colors, if the colors can fly, is read the question 3 times. That's what I told the grade 10s. Read the question 3 times. First time to identify the formula. We have identified it. Second time to collect data. And third time to make a conclusion. So this is the first time. I just read it once. I didn't even finish it. I identified the formula. Now I'm reading it again. NOMSA started working on 1st of January 1970. At the end of January 1970 and at the end of each month thereafter, she deposited 400. So this 400 is very important. Why? It is X. It is the constant amount. And then into an annuity fund. She continued doing this until she retired on the 31st of December 2013. So it means the number of years is going to be what? 2013 minus 1970. And then we'll get what? It's 43. One thing we have to be conscious of is the 2013 involved as a year? Did it happen? Is 47. Did the entire 2013 happen? Like, are we going to include it in the calculation? Let's verify, guys. 43. Okay. Let's wait for you. What do you get? You get 43, right? Yeah. Should be. 43. Okay. So check what I'm saying. What you should be conscious of, like 2013. Should we include it or not? Here's how you answer the question. Why am I saying that? It's because if her last day at work was in January 2013, we can't include it in our calculations. Yes. Because the entire 2013 she did not work. You get what I'm saying? Yes. So it happened until 31st of December 2013. We are including it. 1970, was it in December such that we will start calculating from 1971, or in January such that the entire 1970 is counted? It was in January. Now things are okay. Just be conscious of that. And then you multiply this by what? You will look for your compounding. Remember, this is number of payments, not just years. So when we are reading further, it says, determine the total amount that she paid to the fund. So are we given, the total amount that she paid to the fund. This is our data on the side, right? So when answering questions, we know that most of the information will be coming from here. They are saying how much amount did she pay into the fund in total. It's simply 43 times 12 because she was paying every month. How much is it? 500. That means she made 516 payments. But how much money did she make? How much money did she pay? Is 516 multiplied by 400. Because if she paid once, it's 1,400. If she paid twice, it's 2,400, which is 800. She paid 516 times. It makes what? How much? 206,400. 206,400 rands. That is how much she paid into the bank in total. She was very consistent. She didn't get any dismissal at work. Well, it's a theoretical case, but it can happen. And then they say the interest rate on this fund was 8%. We are going back to our collection of data, 8%. And they are saying per annum compounded monthly. I advise that you divide by 12 immediately here. So when you go to the data, you just substitute. Even here you see I can multiply by 12. Why? The compounded is monthly, which is 516 payments. We've already done it on the first question. So this one was 1.1, right? 1.2 it says, that is the interest rate. They say calculate the value of the fund at the end of the time she retired. We check our data. The only thing we don't have is F. And that's what they are looking for. We go to that formula, we substitute. So F equals to X into, you must write the formula first, guys. Don't just start by substituting. Because the marker won't know, cannot predict that this person was actually using this formula. And then from here we have 1 plus 8% over 12, close bracket into 516 minus 1 over 8% over 12. Don't make a mistake. Write the percentage. After writing 8, make sure the percent is there by shift, by having shift and what? Shift close open bracket. It will give you a percentage. So you will say 8 shift open bracket. It will give you 8%, and then you continue. Or you convert it from here and say 0.08 over 12, because 0.08 is the same as 8%. What do you get as the fund?
1,789,977.
1,500,000?
789,977.
789,977 and
22.
so since it's money, we can just say 22 cents. But if it was just a value, you will call it when we just say 0.22, because we can't call the value after the digit, after the decimal points impact. You can't say 22, 220, you say 22. But since it's money, we say it's 22 cents. So this is approximately 4 to 5 marks. Actually, it's much simpler. This alone should be 4 marks. 3, 4 marks. And then adding with this one, approximately 2. So the entire thing is 5 marks. Was there any sweating? No. Why? The strategy is here. You read a question, you identify. You must be calm. Is it once off, continual? Once you have once off, you check which formula. Don't rush. Once you get the formula, collect data based on the formula. So your formula is informing the data you are looking for. Then let's see. This one is where we will do extra calculations. Let's see. It says on 1 January, on the 1st of January 2014, Nomsa invested 2 million in an account paying interest at 10% per annum. Remember, when she retires, she will get her retirement money, her UIF money. They will all come in on top of the money she has been saving for herself. So she can add on this money and save 2 million. Yeah, this person is very disciplined. I don't know if I've met someone like her. Once I get this money personally, you wouldn't see me here. But yeah, discipline is needed. So they are saying, so remember, I have to read the question how many times? 3 times. The first one, did I read it 3 times? No, I made a mistake. So why for the 3rd time is to ensure that I have done the proper conclusion. Because for example, maybe they will be saying, will the money she has, just an example, will the money she has be over or below 2 million? And when I just calculated and ended here. You see that you did not conclude. So you need to go back and read. Have I concluded? Calculate the value of the fund at the end, at the time she retired. So you can make a conclusion and say, she retired having this much. You can just write it down. So it becomes much simpler that way, isn't it? Happy with that? It seems simple, but it's not. What makes it simple is what? Is the strategy. The strategy. The strategy makes it simple. So let's read this one 3 times. It says on the 1st of January 2014, Nomsa invested 2 million in an account paying interest at 10% per annum, compounded monthly. Nomsa withdraws a fixed amount from this account at the end of each month. We can pause there and conclude the formula. Is it once-off payment or continual?
Once-off.
Read it, Jabo.
Continue.
It's continual.
You see?
Yes.
So the fact that she paid, it doesn't end there. Is she getting something immediately or she will wait? So it says immediately after paying, she starts getting constant amount. And most people do this, those who retire. They will get a large amount of money, for example, let's say 900,000. And then that 900,000, they are advised to put it in the bank and choose an amount that they want to get every month. Imagine you are getting paid from your own money. Pellet your own. You can choose to both at the same time. But you'll be advised to not. Because you can take 900,000 is too small. It doesn't even deposit my favorite car. So we picked that it's a continuous payment. Okay, that's what we picked. All of us are okay with that. Why are we saying that? Nomsa withdraws a fixed amount from this account at the end of each month. That is clear English, guys. It doesn't need an interpreter. It doesn't need a prophet. Clear. Only if you read it with understanding for comprehension. Then, it means if you write any of these formulas, here. Which one is it? Is it future or present? Now we look at where is the larger amount. Did it happen presently or in the future? It is present. Why am I saying present? She is the one who paid the large amount. And then the bank is paying her back based on the money she put. And then if it happened that she did not pay the amount and the bank is paying her for what? The bank cannot loan you every month. Or every month will loan her 2,000. Directly to you and then you will pay at the end. That one will be something else. So instead it will become a present annuity. And we also know it as a loan. So she loaned the bank. And the bank is paying her back every month. The bank can loan you and you pay it back every month. So our formula is P is equals to X into 1 minus 1 plus I to the power of negative N over I. So you collect data. Remember, check, if you can check well, I'm collecting data before I go to the questions. Because I know this is the formula that will be there. It will be the most famous formula in this specific question. So I'm going to do this one and then I will give you questions to do. You will do question number 2. So now I'm reading the question for the second time. On January the 1st, 2014, Nomsa invested 2 million. 2 million. It's the present amount. In an account paying an interest of 10% per annum. 10% per annum. I don't need to mention the annum. It says compounded money. It says Nomsa withdraws as fixed. She should warn us first by saying, then you can do wool at that. All of it. Imagine at night it's dark. You're working. I will fly. Okay, let's proceed. So check. So Nomsa is withdrawing, right? They are saying 10% per annum compounded monthly. I've connected that. They say Nomsa withdraws a fixed amount from this account at the end of each month, starting on the 31st of January 2014. If Nomsa wishes to make monthly withdrawals from this account for 25 years, and she doesn't get old, for 25 years, then we multiply it by 12 because we are looking for the number of the payments to be done. What is 25 multiplied by 12? 300. 300? Yes. So it's 300 payments. That is what we are expecting. Okay. That means she wants the bank to pay her 300 times. Now, we have to help her by determining how much she will get every month. They say calculate the minimum amount she could withdraw at the end of each month. Then we continue to look for X. Then we write. Now, here's the trick, guys. Here's the trick. Now, I will be answering the question in this case, 1.1.3. So I start with the formula. Something very important that people make a mistake on is this, and it will help you on your assessment. You can see that you are looking for X. Don't substitute. Solve for it first. It helps a lot. Because if you substitute, this P is 2 million. You will have to write this 2 million several times and it wastes time. 2 million, later on 2 million again, while solving for X. Of which the simpler one, I will come to you, the simpler one is to say, let me solve for X. Instead of writing 2 million, I just write P. I will be multiplying both sides by I, so it will be Pi equals to X into 1 minus 1 plus I to the power of negative N. I'll come to you just now. and then you divide by this, both sides. Before you even substitute, then now I can substitute. Substituting to what? Pi 1 minus 1 plus I to the power of negative n. That means my x will be 2 million. I'm writing it for the first time. Multiplied by the percentage, which is 10% over 12. All over 1 minus 1 plus 10% over 12. Then this is all to the exponent of 300. Then I look for my x. Yeah, you had a question?
So say, like, okasuma so x and then substitute sakoyona, penalty.
If I may ask, what will be the penalty for?
No, like.
Okay, so
You changed the like.
the formula.
Yes.
No, I did not actually. So the fact that I have written this down, I am showing the marker. Remember, this is a language I'm speaking with the marker. When the marker reads this, they should understand it, provided they did maths. So when they see this, yeah, provided you can bring someone who did not do maths to mark. No, it's not going to be proper. So this formula is given, they know it. Then now I'm showing the marker that I am solving, right? How do I show the marker? I have pi, it shows that I multiply both sides. Which is what I would do if I had substituted. I was going to multiply both sides by 10% over 12. So in this case, as long as you wrote this, don't come having written this. Because it might confuse the mark, even though it's correct. But show us, where are you picking it from? From the given equation in the formula sheet or the data sheet. It makes some sense. So this has two languages in it. There's a language of finance, which is this formula. Then there's a language of algebra, which is the solving for x. So when I'm solving for x, there is no much of awarding of marks. Where are they awarding marks? Choosing a correct equation can be awarded a mark, and then substituting,
Into the correct form.
getting the answer, the unit. Because I can't just go there and say 1 million. 1 million what? Dollars? Bananas? People? What is it? So can we get the answer to this, anyone? And don't forget to put the percentage. Is what?
18,174.
I think I will be like this person. No, 18,000?
174,01.
You.
01.
You. Hi, this person is earning my feet. By losing only 400 per month. For 25 years, earning. Okay. Now I'm reading the question for the third time, for the sake of conclusion. You will read it all, but at the end it says, calculate the minimum amount she could withdraw at the end of each month. Then I can make a conclusion here and say, she can withdraw from, because they said a minimum, right? From 18,174 and 1 cent. That's the amount we have. Simple as that. Now, the last question for this question, the last sub question. Any question here? We are okay. No? It seems easy. No? I'm flowing. We will wait for question 2. You will see. That's what I like about financial math. I remember 2021, I was at a certain school during my practicals. I got there when they were doing finance. So I taught it the same way, just that I modified it a little bit to make it better. But I taught it the same way. They seemed like they understand. Everything was fine. It was a week before prelims. You know that in the entire grade, those who are doing maths, they were over 75. Only one person got at least 50% in a question of finance.
Yep.
Others just left it. Why? You are looking at someone doing it, it's easy. Or when you're choosing the equation, it's not easy. You had Jawed first quickly set ones off. But what if I'm not there to actually tell him to pay more attention? He will choose a ones off formula. And later on he's surprised that the person is paying every month. And now he's done calculating. It becomes an issue. Let's see 1.2 quick. 1.2 says, I do the same thing, guys. You stay calm. You read the question 3 times. First time, to identify an equation. For each of the 3 years from 2010 to 2012, the population. I don't read further. Why? I know a population cannot be continual payment. And it's not even a payment. Rather, for a population, I'm going to use once off, and I'm going to use what? Compound interest. So I know that on my notes aside, I know that I need compound interest where the data simply is I must find A, I must find I, and N and P. So I read the question again now, for the sake of finding those. They say for each of the 3 years from 2010 to 2012, the population of town X. What did they say for each of the 3 years? Population of town X decreased by 8%. Decreased by 8%. Let's relax a bit. You know why? They did not say 8% per annum. So I can't treat it as an interest rate. That's a decrease. It means from where it was, it decreased by 8%. That means it's the present and the future. The difference is 8%. If there were 100,000 people, they decreased by 8%, which is 8,000 or 80,000. Therefore, it's 8,000. Therefore, in the next year, the population is 94,000 or 92,000. You get what I'm saying? Okay. Per year, they say it decreased by 8% per year. Now we can conclude and say this 8% is per annum or per year. Then it becomes the interest rate. Making some sense? They give you, they say 8%. They don't include per year. It's not interest rate. Interest rate, it must be per annum. If they have a compounding, let them have it. And I say, and the population of town Y increased by 12% per year. So that means we should have two data here, two set of data. So the first one is 8% per annum, which I can just leave it as that. And then the second one is what? A, P, I, and N. So this is for X and this is for Y. So for X, it's 8%. For Y is how much? 12%. And then N is 3 years. One thing to notice, they said this one increased. We are using interest. This one decreased. Never. Let me start again. This one increased, right? We are using interest. Again, this one decreased. We are using. Is it like you are not sure? Guys, the formulas are here. They are clear. It's once off. We know they are here. Are you going to use interest for this? No. Therefore, it becomes depreciation. I wanted you are not sure. You are not sure. So I'm asking you, 1 plus 1 is what? You said 2. I said 2. Maybe 4. You must be sure. So we'll use depreciation because it reduced in value or its value decreased. Okay. Then they say at the end of 2012, which is the last year, the population of these two were equal. Now that's important. The population of these two were equal. So it means is that future? Okay. I can make it X. Both of them are X, they are equal. Now, what is the present? The present for this one, for P, remember it decreased, right? It decreased by how much? By 8%. It means if I was having X in year 1, by year 3, it's not just X, it is rather X minus 8% of X. Why? Because it decreased by 8%. And what is 8% of? 8% of the X. You get it? Then it means my P is going to be, let me check. So I'm going to reverse it because I made X to be in the future. So I'm going to say this. I'm going to say in year 1, I don't know how much I have. But in year 3, I'm having X. This X actually increased by 8% from a previous amount. So I'm going to say there was X, which had 8%. And then when it comes this side, it will decrease. If it confuses you, do not make this X. Just put it as A for now, and then make the arrangements. I know it seems hard, but it's not. I made an example. If you are having 100 people in a town, they decreased by 8%. That means you have 80 people now. Sure. You'll be having 93 people.
So let's leave it.
You are not getting anything. 99? 92%. Yeah, 92. Now, how do we get 92 from 100?
100 minus 8.
So let's make it a variable. We know that we were having 100 people in year 1. In year 3, we are having 92 people. How can we get that through variables? Okay, simple. This one is 100. We understand that it's fine. Again. So this one, how can we write it in terms of 100? We will say this is 100 minus 100 times 8%. Agreed? Because this will make 8. Then it's 92. You're okay with it? Then if you want to write this side as 92 and write this in terms of 92, which is what I'm attempting to do here, you're going to say what?
100.
There's no 100. You don't know 100. You are writing 100 in terms of 92. You're going to say 92 plus
100.
Plus, yeah.
8% of 100. You don't have 100. Hi guys, it's fine.
You lost.
You are lost. Let's not lose you ahead from here. So let me explain the question again. Maybe you'll get it this time around. Check. I am having town X from the question. You agree? Then I have town Y. Agreed. Town X decreases. Am I lying or it's correct?
Correct.
It decreases by what?
8%.
What does that mean? If you do, there were 100 people, now there are 92 people. 8% of 100 is 8, means we say the future population is 100 minus 8, which is 8%. It decreased. So we are using depreciation. Depreciation that we are using, okay, without even getting to the formula, we are having this, right? For once off, these are the variables we need. Do we have the future amount? We don't have it. Do we have the present amount? No, but we know the difference between them is 8%. You get what I'm saying?
Yes.
The difference between the present and the future is 8%. For interest, we have it is 8%. For N, how much is it?
3 years.
It's what? 3 years. Perfect. So now the goal is to find this, the difference. How can we get that? Let me ask you. In terms of variables, let's say we call it A. It's not mature. Eh? So would you agree with me if I do the following? Check. If I say P is the present value, in the future, this P increased by 8% of itself. Well, it decreased. Would you agree with this?
Yes.
8%. 8% of P. Would you agree to that?
Yes.
Then let's leave it there. Let's not complicate things. That's how it is. That means I have written both values, A and P, in terms of only one variable, which is P. So what's difficult if I write X here? Because there is no X in financial math. Okay, it's fine. Then this side, it increased. This question was very nice, isn't it? It increased. It increased by what? 12%. And then the years is the same. Presently, how much is it? Remember it increased. It's just P. Ne? You know what's difficult? What's the problem? This P and this P are not proven to be equal. Therefore, I must use a different variable here, maybe x. You'll be happy with that?
Yes.
And then here I will be saying x plus 12% of x. That means I've increased by 12%. Agreed? For sure.
Sir, what is at the end of 2012? Like a population now, it was about equal. Some were able to form equal.
Before we equate them, we need to understand the information in each population. There is an unknown, yes. The unknown will be found by equating the two. Where? At the end. Because at the end, population X and population Y will be equal. We are okay with that?
Yes.
Making some sense?
Yes.
So here becomes the problem. I know it's easy, okay? Here becomes the problem. I am having P and I'm having X. Let me show you how. I have P minus 8% of P, which is equals to X plus 12% of X. I am supposed to have only one variable to be able to solve. Hence, I was forcing what? To rather write P here and write this in terms of P. Or X, you can say.
So why are we not using A?
Why am I not using? Oh, I can use A. It's fine.
Yeah.
And write P in terms of A. But it's fine. Let's just continue working. Let's see. You are having P minus 8% of P. What is 8% of P? 8% is what? Agreed. No?
Yes.
And then P is just 1P. So 1P minus 0.08P. What do you get? 0.9. 92, right? So this will be 0.92p. This one is a plus. It's 1.12x. Agreed? Because 12% is the same as 0.12. You add it with 1, it will be 1.12. Scenario is not make sure. We are being killed today. No, I can see you guys, most of you are still confused.
Let's continue.
Giving you the answer while you don't understand it is utter nonsense, it's useless. Let me read the question again. For each of the 3 years from 2010 to 2012, that's 3 years, okay? 2010, 2011, 2012, it's 3 years. It means 2010 we started from January, and then we went to 2011, then 2012 we ended in December. That makes it 3 years. The population of town X, that means we are dealing with a population of town X, did what? Decreased. It's a population, if it increased, it's compound interest. If it decreased, it's reduced balance method. So it decreased by 8% per year. That per year is per annum. It qualifies it to be our interest rate. If there was no per year, it was not going to be an interest rate. You agree? Let's pause it there. Let's understand the data. What can we do with just that data given? Your brains are tired from lunch.
From the question.
From the?
Question.
From the question.
Okay. Say A.
Okay. No, let me answer it. You allow me?
Yes.
You allow me to answer it?
Yes.
Will you be happy?
Yes.
Okay. Let me answer it. Maybe you will be fine. Check. And let me answer it as if I'm reading it for the first time. Then just take along. Even if you don't get it, just take along. Pay attention. I will be writing the same things. You know, teaching is hard. Writing the same thing over and over again for the sake of transferring the information to the next person. Hey. Now, just keep quiet, stay strong, and listen. I'm reading it for the first time. For each of the 3 years, from 2010 to 2012, the population, the mentioned population, I know it's compound interest. Okay? But now they say decreased. Interest doesn't decrease. Therefore, it becomes reduced balance method.
Yes.
And I say there is a population called X, and it is decreasing. Data on it, on this population X, will be A, P, I, and N. So what is my A? I don't know. What is my P? I don't know. What is my I? 8%. What is my N? 3 years. That one we've been getting it right.
Yes.
The difference between the future and the present is 8%. So I'm going to call the present to be Px, ne? Because it's population of X. And I'm going to call the future to be P of X minus 8% of P of X. And this in simple terms gives me what? 1 minus 0.08, which becomes 0.92 P of X. That's population X. The formula is perfect. I'm done there. Go to which increased. When I read the question, it increased. And then the data for it is what? A, P, I, and N. So P is what? A, I don't know it. P, I don't know it. But I know I, which is 12%. What about N? 3 years. Between the future and the present, one thing I know is that it increased by 8%. Therefore, P of Y for the future will be P of Y plus 12% of P of Y, which gives me what? 1,12 P of Y. We are okay with that? And then I continue reading the question. Remember, by how I advised you read the question twice. First for choosing a formula. Secondly for collection of data. Okay. We have to read it for the third time. You were so confused because of this part. Determine the ratio of the population of town X, call it Px, to the population of town Y, call it Py. Did you read that before? Or are you seeing for the first time? You didn't read the entire question. At the beginning of 2010. Not in 2012. At the beginning of 2010. At the beginning, yes. That means I have to say the beginning of 2010, I call it Py. The beginning of 2010, I call it Px. But what I equate is the future, which is after 3 years. Then I equate the future of X and the future of Y. They are equal according to them. But what is the future of X? Which is 0.92 Px. What about the future of Y? 1.12 Py. How do you find ratio? Ratio is the same as division. And I listen. They say the ratio of Px to Py. That means Px should be at the bottom. I divide both sides by Py. I'm going to divide both sides by 1.12 Py. 1.12 Py. It cancels, it is left with 1. Okay. 0.92 divided by 1.12. How much do you get? 0.8. 82. Okay. But remember, what is this? It says what? Px over Py. And this is equals to? 1. And then, to make a ratio, those who do accounting, this should be a staff. I know it's traumatizing you, but this should be a staff. When you come to the ratios, check. I want to have a ratio. Already this is a ratio. But in terms of numbers, I don't have it yet. I take this number to that side. How do I take it? By dividing it. So I'm going to divide both sides by 0.82. And then what do you get? Px over Py is the same as what? What is 1 over 0.82?
1.22.
1.22 over 1. You agree?
Yes.
Will you agree?
Yes.
Someone doesn't agree. This here is a ratio on its own. Px over Py equals to 1 over 0.82. It is a ratio. I can stop here, but I'm just simplifying it. to say this 1 over 0,2 is the same as 1,22. That means the ratio of px to py is the same as 1,22 is to 1. You know what tricked you? Because we took time very deliberately. What tricked you is several issues which you need to fix. First, you predicted what the question should have. Tell me if I'm lying. According to your thoughts, we were supposed to use a compound interest formula and calculate.
Yes.
Isn't it?
Yes.
No, it's good to expect it, but do not want to force it. Someone was busy thinking, but how are we going to use the compound interest here? How are we going to use the compound interest here? Read the entire question first time. Read again second time. Read again third time. You shouldn't have had a difficulty in answering this. But then what can we say?
Sir, not wrong. Molamo px over py is equals to 1 over a2. Why ratio not from
Is
there?
equals to 1 over?
0,8.
No, it wouldn't be that wrong because it's still a ratio. Saying px is 2, py is the same as 1 is to 0,82. It's the same thing as this one. And also this one. It's the same. The same values. Just that we know that the ratio we should equate to a ratio of 1. What is to 1? What is to 1? That's accounting. Yeah. So this is accounting people. But you can end it here. It's still okay. 1 is to this much. It's still a ratio, isn't it? They didn't specify that it must be to 1. They just said, give us a ratio. And ratio is given from definition. From division. Happy with it?
Yes.
Not happy? Yes. I see it's already 25 past. Let's verbally answer a question
Yes.
without writing it down. Question 2. Can someone read it? And be calm. When you read it, be calm. Someone?
Exactly 5 years ago,
Exactly 5 years ago. Get that to your brain. Exactly 5 years ago.
Mpumi bought a new car for 145,000.
Okay.
The current book value of the car is 22,500. If the car depreciates by a fixed annual rate according to the reducing balance method, calculate the rate of depreciation.
Then, now I fix something. We have read the entire question with one purpose, one goal to identify the equation. Can you now tell me which equation to use? The reduced balance method. First, it's a once off because she didn't pay every month. Secondly, it's a depreciation. The car decreased from 145,000 to 72,500. And then it is specifically a reduced balance method. Now, read it again, but having written I said we are doing verbal. Having written the formula for what? For reduced balance method. Your data should contain this. The A, the P, the I, and the F. You don't need X, you don't need F, you don't need the big P here. All you need is these variables you find on the reduced balance method. Then you read it again now. For filling in this data. Once the data is filled in, you will be able to calculate, isn't it? Yes. Then you will read it for the last time for the sake of conclusion. Can you read it again?
Exactly 5 years ago.
Pause. 5 years. You see what I'm doing? At first I didn't care about the 5 years. But now I'm taking careful consideration. 5 years ago.
Mpumi bought a new car for 125,000.
Now, if they are talking about the past, I take that past as is my present. And then I take the future as the future of the present as the future. So that was 5 years ago. I'm taking it as the present because there is no past in this formula. There's only present and future. So that means it is 145,000 present.
The current book value of
The current book value, which becomes the future, it becomes 72,500.
If the car depreciates by a fixed annual rate according to this reducing balance method, calculate the rate of depreciation.
Calculate I. Now, I'm tempted. I said we are going to do it verbally because of time, but I'm tempted. I'm tempted. No, I don't want to lie. What do? You solve for I first. You get it? Okay, solve for I first. Divide both sides by P. Then you have A over P is equals to 1 minus I to the power of n. To remove the n, you use log. Isn't it? So I'm going to say, when there's, let me check.
Square root of n.
You can put the square root of n.
Nth root. Nth, yeah.
Nth root, or you can use logs. You know how?
Yes.
Okay.
No,
Nth
we
root.
don't.
You don't? No?
Yes.
Some don't. Hey, Jav is tired. He just wants to go. Check, Jav. You are having A over P equals to 1 minus I to the power n, right? You introduce a log both sides. You introduce a log both sides. 1 minus I to the power n. Then by a law of logs, you remove this n to come here. You know that law? Yes. Then it comes here. Because of time, I won't write it all. Then you say all over log of 1 minus I. Even this side over log of 1 minus I. Then according to the laws of logs again, if you are having this arrangement, you can just write it as log of 1 minus I down here. And then this one up there. This is equals to n. Or we can give it the nth root. Nth root both sides. Then it removes itself, right? Yes. Then this side we are having nth root of A over P equals to 1 minus I. You are looking for I. It's best to transpose it to that side and bring this one this side. Now this is algebra. If you don't understand me, just copy this and solve for I on your own. On your own. Let's see now. I just solved the I. Here you might have a problem because of isolating this I. Because we are not specifically solving for n. But you can solve it if you stay strong enough. Then here you'll have I equals to 1 minus, what is n? You see now it becomes much easier. A, P, then you get your I. You multiply by 100. The value you get, you multiply by 100 because you will get it as a decimal. Make it fast. 12 comma? Nkosi yami. T. Why is it not go? Hey, let me put the marker here so I don't write. Can someone read 2.2? Someone read 2.2? Offense, you can read it for us. Remember, why are we reading it now? We are reading it with what goal? To get the date. The first one, we read it only twice. You see, we are lazy. We are supposed to read it for the third time. Where we make a conclusion. Okay, offense, you can continue for us to select a formula.
Samuel took out a home loan of 100,000 with an interest rate of 0% compounded month. He plans to repay this loan over 20 years, and his first payment is made one month after the loan is granted.
Which formula? First, which payment? Continuous or once off? You know what's nice? Someone has an answer, but they are not bold until they hear someone mimicking the same answer or mumbling the same answer. Then they start to be confident. In an exam, they won't be that person. You'll be alone. Trust your own decision. And don't just decide out of the sake of just deciding. Decide with reasoning. Did Samuel pay? Okay, did the payment between Samuel and the bank happen only once?
No.
If you think it happened once, read it again. If you think it happened twice, read it again. It says he plans to repay this loan over 20 years. Logically speaking, you cannot say, I'm repaying over 20 years. I will repay the whole amount at the end of 20 years. Doesn't make sense. And what debunks that idea is made 1 month after. So you can say, I will pay 20 years, then 1 month after I pay. and then you are still continuing. It means it's a continuous payment. And then, is it present or future? Present, because he received 500,000 manje. Present annuity. You see that is the main goal. Then read it again, offense for collection of data.
Somebody took out a home loan for 500,000.
What is that 500,000? XPIN. It's what? P. Okay, we proceed.
At an interest rate of
12% per annum. I.
I.
Which is over
12.
Okay?
compounded month. He plans to repay this loan over 20 years.
And 20 years. Multiplied by 12. It becomes 240 years. 240 payments. I know.
Yeah, 240 years.
Okay.
And his first payment is what made 1 month other than
No, that is a normal case. You can't ask for, guys, think. You can't go and ask for a loan of 500,000 and immediately start repaying it. Nahana ke tla go wena ke re nka dime 10 rand to be bush. A o fetsa mpha yona go fa ranta ke ra ke thomile go patela. It can happen. So now I'm ready. I know the information given. Calculate the value of someone's monthly installment. You are solving for X. Solve for it, substitute later. Done. 4 marks, 5 marks. Melissa 2. Yeah? Took out. He made a mistake. Yeah, let's make sure. Melissa took out Evan. It's correct. Hey,
Melissa 2 out for the
Melissa 2. There's a need for a comma there. Melissa 2 out of the same amount. Yeah, they need a comma here. Melissa 2, comma, out of the same amount. And at the end, Evan, at the same interest rate as somewhere.
out 4.
Out for what? Okay, no, it's fine. It's a loan. Let's say took out there. You remove the 4. Yeah, I'm sure they fixed it. There was an addendum during that day, I'm sure.
Let's continue.
And then next. Melissa took out the same amount, and at the end of each, at the same interest rate as somewhere. So it is the same 12% per annum. Melissa decided to pay 6,000 at the end of every month. So now we don't have, what is that we don't have? For Melissa. Remember I are done calculating for somewhere.
N.
We don't have N. Because F, they are saying same amount. I, they are saying same interest rate. X, they've given it to us. We need N. We don't have it, we solve for it. Calculate how many months, which is N, which is the same as how many payments. Who pays more interest? How do you calculate that? You check. There are 2 ways to check it. The first one is who paid for longer. Likely they are the ones paying more interest. Between Samuel and Melissa. And then the other thing you can check is calculate it. Check who got more interest. Check how much did someone pay at the end of the. For example, if for someone you got 5,000 per month, say 5,000 times those number of years, you get the whole amount he paid. You go to Melissa, 6,000 times the number of months you have. You will get the whole amount that Melissa paid. You compare the two. That's another one, which is more proper than any other. So I'm gonna send you this thing, guys. I think physics, you are tired for you today.
Yeah.
You are saturated. You go and rest. Tomorrow is back to square one.
Send the
Let's go.
chocolate.